Hello everyone, today we'll be talking about memoization. We're going to use the Fibonacci series as an example. So what is memoization? It's basically caching the recursive calls. Why do you want to cache the recursive calls? Because in a recursive function, you might have multiple calls that are the same or repetitive, and you want to store them. So that way you only call them one time. All right. So for example, in the last video when we traced the Fibonacci function recursively, we saw multiple recursive calls being called at the same time, repetitively. So we saw repetitive recursive calls when we try to trace the Fibonacci function in the last video, like Fib1, Fib2, Fib3. All right. So that way, when you use memoization, you cache them. You only store that. You only make that recursive call one time. And if you see it again, you get it out of cache and you reuse it. All right, let's go through this Python code. We'll probably explain it better. So we have fibm and this is our base case. And you can see right here and here from the main here that we have the first two numbers of the Fibonacci series. All right, and here, if it's not in the dictionary, we call these dictionaries in Python. We just do the recursive call, and then we call it our dictionary, and then once it's called, we put it in our dictionary. Once it's put in our dictionary, we call it, and if we see something that we recognize that has already been stored, we just call it and return it. All right, so let's get into it. So I just want to be really quick here. Right here is the key is the number of the Fibonacci call. So like, let's say this is n, key is n, and the value is the Fibonacci sequence value. So this will be the order, and this will be the Fibonacci sequence value in value. We're going to put that there. All right. Let's trace it. All right. We're to keep things short, I know it's supposed to be fibm. We're just going to use fib, and I'm not going to add the dictionary and the parameters. Six. Five. Four. Three. 2. Okay, once we're at 2, you'll see that we reached our base case, and we go into our dictionary, and 2 take away 1 is 1. So just want to make this clear, when you're doing recursive calls on on the tree, so anything on your left side is n take away 1. Anything on your right side is n take away 2. Right side, n take away 2. Left side, n take away 1. So when I do this recursive call, yellow means I'm getting it from the dictionary. So 1 is called. 2 take away 0. So say 2 take away 0. Sorry, 2 take away 2, because we went on the other side, sorry. 0. So right here, we store it. 1. 1 for 2. We go to 3. 3 take away 2, which is 1. So this here will be 2. So for 3, it is 2. Left side, 4 take away 2 is 1. Why did I do that? So just here, just do this. So 2 plus 1, get rid of that. Is 3. Just want to make this, do I make the 3 clear? 3. So 4 is 3. Oh, start. I don't want to get ahead of myself here. You go 5. All right. 5 take away 2 is 3. Okay. And 3 is 2. Value for 3 is 2. So 3 plus 2, 5 is 5. And 6. 6 take away 2. Oh, hold up. Stop here. 6 take away 2 is 4. Sorry. Okay. So we get 4 here. We go to the index, and it's 3. So 5 plus 3 is 8. So 6 here, we get 8. And that's the end result. And the time complexity here is O of n. And I just want to make something clear. When you recursively going on the left side, it's n take away 1, n take away 1, n take away 1, n take away 1, and right side is n take away 2. All right, thank you for watching, and I hope you enjoyed this video.